All right, looking at the union and intersection of intervals. You have to be careful on this one. They switch the union and intersection around, so pay attention to which one they're asking for. The union kind of looks like a U, is like when you have an OR. It can be in this set or this set. So when you do the union, anything that gets graphed in either interval is part of your answer. The intersection looks like the upside down U. The intersection is where do they overlap each other. So on this one we have D is the set that Z such that Z is less than or equal to 4, and E is the set Z such that Z is greater than 6. So what I'm going to do is I'm going to graph them on the same number line, but I'm going to use two different colors to highlight which way they go, so hopefully you can see what I'm talking about there. So if I go over to my scratch paper here. So if I have my number line, my two values, I have a value at 4 and I have a value at 6, so I'm just going to roughly estimate where those two values are. The first one says it's less than or equal to 4. If it's less than or equal to 4, I'd have a filled in dot. I'd go everything to the left, which means that it's going all the way down to negative infinity. The other one was greater than 6. If I'm greater than 6, I would have an open circle at 6. I don't go everything greater than 6. And so that one's going to positive infinity. See, my green marker doesn't want to write very well, but I think you can see that. So when I do these ones, I like to do the intersection first because the intersection is easier, but watch when you do it on Alex that you put the right one in the right spot. So this one does ask for the intersection first. The intersection is where do they overlap? In other words, what do they have in common? All right, so if I look at these two graphs, you can see that they don't overlap anywhere. There's a space in the middle. This one has all the numbers less than 4. This one has all the numbers greater than 6. So where do they overlap or what do they have in common? They don't have anything in common, so your answer is the empty set symbol. It looks like that. My union, D union E, is anything shaded from left to right on the graph. What you're listing is anything that you have in either set. So this one has two different sections that are shaded because of the space in the middle, and since there's two separate sections, you have to list them separately. So the first section from left to right goes from negative infinity to 4. So negative infinity to 4. The 4 is going to have a bracket because it has a filled in dot. The only time you use that bracket is if there's a filled in dot, otherwise you'll be using a parenthesis. Since there's a second section, you're going to join it with the union sign, and then you're going to do the second section from left to right, goes from 6 to infinity. Both of those are going to have parentheses because you have an open circle, you're not on the 6, and you can never be on the infinity, and that's what the parenthesis means, is you're not on that value exactly, as opposed to the filled in dot where you have the bracket, you are on the value. So if your graph ends up being two separate directions and a space in the middle, your intersection should be no solution, your union should be two separate sections. Now I'm going to pull up another one here from your pie chart. That's the one that you missed. Let me look at the next one here. All right, on the next one, I'm going to slide this over so you can see that next one. I'm not sure if you wrote these down or not, but on the next one, B is the set Y such that Y is greater than 1, and C is the set Y such that Y is less than or equal to 9. So again, I'm going to put those on my paper here and look at how they look. So let me flip this over to the other side of the paper. And my camcorder on there. So this one again, I'm going to make my number line. My two values, I have 1 and 9. Again, just find a spot for 1 and a spot for 9. They don't have to be exactly. This one I am doing greater than 1. If I'm doing greater than 1, I'm having an open circle at my 1, doing everything greater than, so that one is going to positive infinity. On my second one, I'm going to try my orange here. Less than or equal to 9. If I'm less than or equal to 9, I have a filled in dot at 9. I'm going everything less than, and so in this case, I'm going to negative infinity. So I have my graph. Again, I am going to do the intersection first. This one actually asks for the union first, but I think that the intersection is easier, so I'm going to do the intersection. B intersecting with C. Where do they overlap each other? They overlap each other right here in the middle. These values would be in both of my sets. The values from 1 to 9. Anything less than 9, anything greater than 1 would include both of those sets. So my part where they overlap each other is from 1 to 9. The 1 has an open circle, it's going to have a parenthesis. The 9 has a filled in dot, going to have a bracket. That's actually the second question, so you'd have to enter that in the second spot. My first question is, what is the union? B union C. Anything that is shaded on my graph is part of my union. Here I shaded the values from negative infinity to 9. Here I shaded the values from 1 to infinity. So what happened is I shaded all the values up to 9, but then it kept going to infinity. So my entire number line got shaded either in the less than 9 or greater than 1. There's no gap, no space in the middle. So I'm just going from one end of the graph to the other end of the graph. And so negative infinity to positive infinity would be my answer. Now you didn't have one that looked like this because you stopped working on those, so I'm just going to make up one where what happens when my arrows go in the same direction. If I said A was my set X such that X was greater than 3, and B was my set X such that X was greater than or equal to 5. So if that was my question, and I make my number line, I have 3 and I have 5 on my number line. On the first one, I said that X was greater than 3, so I would have an open circle at 3 going everything greater than, which means everything up to positive infinity. And then I have greater than or equal to 5. So greater than or equal to 5, I'd have the filled in dot. Again, I'm going to positive infinity. So, union and intersection. Again, I'm going to do the intersection first. Pay attention on Alex, which one they do. Intersection is my upside down U. Where do they overlap? Where do these overlap? Where do I have one line right over the top of the second line? From the 5 to infinity is where my graph is overlapping. I've got two arrows, one right on top of the other one. So from 5 to the end of my graph, the 5 has the filled in dots, so I'm going to use a bracket. Infinity always has a parenthesis. My union, A union B. Anything shaded. Here on this end of my graph, there is nothing shaded. I don't have a pink line, I don't have an orange line. The first shading starts at 3 and is shaded all the way to the end of my graph. So anything that is shaded, the numbers from 3 to infinity are all shaded in either graph. It happens to be shaded twice here, but shaded at least once from 3 to infinity. So I'm going from 3 to infinity. The 3 has an open circle, has a parenthesis. Infinity is always going to have a parenthesis, and so my answers would look like that. So when you graph these, graph them on a piece of scratch paper. Use 2 different colors when you're doing them. The intersection, the upside down view, is where are they overlapping? Where do you have the 2 arrows right above each other? Intersection, anything shaded. And so the intersection, the union is anything shaded. So the union will be the bigger section of your graph if they overlap and go in the same direction. If they overlap and they're going in 2 opposite directions, my union ends up being the whole thing. And if they don't overlap, my union I have to do in 2 separate sections. So I'm going to have 2 parts to my answer with the union in between. Hopefully that helps.